Hello everyone, my name is Anak Maharaja Adhisthanaya Indrawan with the number 5022211239 from Electrical Engineering Japan. So in this video I will show you the answer of this problem given in physics. So the problem is in a middle of coil with 3 cm of radius, 10 cm of length, and consists of 1,200 turns. There is a small coil with 2 cm of radius. Length of coil is 4 cm with 50 turns. So to solve this, the first problem is calculate the cross inductance of the system. To solve this problem, we need to draw the coil first. So there is a big coil and small coil. The big coil has 3 cm of radius, 2 times 3 times 10 minus 2, and the length is 10 cm. Times 1 times 2, and this is the length. And the turn is 1,200 turns. And then we know that small is the radius is 2 cm, the length is 4 cm, and the turn is 50. Okay. This is 2 times 10 minus 2 meter is 4 times 10 minus 2 meter. Okay. So after this, we know that there is magnetic flux equation. Is the magnetic flux equation is magnetic flux equal with A times B. So in solve this equation, we need written the equation of magnetic field. So the equation of magnetic field in this area, P equal to 0 times N times I. So as we know that N turns density is equal with N over L. So I will write the equation N over L. So we can substitute the N. So E equal with mu 0 times N over L times I. The mu 0 is the permeability for P times 10 minus 2. Correct me if I'm wrong. And N over L is the turns over the length times the current flow. So to solve this problem also, we need the Faraday law, electric motive force. So the electromotive force equation is electromotive force equal with minus N times P of magnetic flux over dt. So as we know that the equation of this electromotive force can use by electromotive force times equal with minus L also of the inductance times di over dt. So we can substitute these two equation. So the equation will be L equal with N times the magnetic flux over with I. So as we know, this can be the coil itself is not mutual inductance, so mutual inductance is M. So write the equation in here. So M equal with M12 or 21. It can be written N times magnetic flux over I, and we know that the magnetic flux, it can be used the equation the magnetic flux itself can be I forgot to substitute this equation to this. So electromotive magnetic flux, it can be we'll write this equation to this. So magnetic flux equal with A times mu0 times N times L times I. So the equation can be substituted to M is N times A times mu0 times N over L times I over this equation and over I. The I is can be gone. So this equation is finally can be solved. So M 12 is N times A times mu0 N times A times mu0 over L. Yep. And times N. Sorry. mu0 times N over L. So we can input these numbers that known. The N is there is two N. So there is N1 and N2. Whereas the N1 is 1,200 turns, and the second coil is 50 turns. So we can input these numbers: 1,200 turns times A. A is the area. So like this. for more easier, 1200 times A. The formula of A is 3 times A squared. So the equation will be 3.14 times the times 2 minus 2 square times times 4p times 10 minus 2 and 2 is 50. So over 4 times 10 minus 2. So in solve this problem, the calculation will be 2.37 times 10 minus 3 Henry. Okay, this is the first problem that is solved. This is A. So I will give the okay. And then we need to solve this second problem. If the current of large coil is charged at rate of 0.5 ampere per second, so calculate the EMF induced in small coil. So to solve this problem, we need several equation or several the equation. So as we know that B the rate of the current in large coil is 0.5 ampere per second. So we input the equation the Joseph Henry equation is electromotive force electromotive force equal with minus m and 2 times EI over dt. So as we see, this is minus 2.37 times 10 minus 3. Di over dt is as is known as 0.5. So calculate with 0.5, and then the calculation is minus 1,19 times 10 minus 2. this is the fault. Oops. Okay, this is the second solution. So we need the third solution is calculate the energy density in large coil if the current through it is 0.1 ampere. So this is C. The third problem, calculate the energy density in large coil if the current through it is 0.1 ampere. So the energy density, as we know that the equation like this, E energy over GAA times L. So in solve this equation, we need the energy curve. So we calculate the energy is a half times L inductance times I or the current square. So the energy equation, if the equation into the problem, or this case, we input the energy 1 over half times M times the current. So the energy can be solved 1 over 2 times the M to 2.37 times 10 minus 3, and the I is 1, 0.1. Okay, and then we, after calculate this problem, we get that the answer is the 1.19 times 10 minus 5 joule. So in this equation, in this energy can be put to the equation. So the problem can be solved. Energy density energy density equation can be input the energy 19 times 10 minus 5 over and this is the A times L. So we need to calculate this. The A is V times R squared. So the A can be written this V times the R is 3 times 10 minus 2 squared times 10 minus 1. This is the length. So this problem can be written like this: 1.19 times 10 minus 5 over 3.14 times 3 times 10 minus 2 squared times 10 minus 1. So this problem can be solved. The energy density after calculate get 1.26 times 10 minus 3 joule over m cubic. So this is the problem solved. The first problem, the cross inductance is solved by 2.37 times 10 minus 3 Henry. The second problem is calculate the EMF in small coil. The number is minus 1.19 times 10 minus 3 volt. And the third is calculate the energy density, which is 1.26 times 10 minus 3 joule over Kelvin. So this is the solved video. Thank you for watching.